once again, I guess I should have reviewed the video before uploading it. So I'd like to make a quick addendum. Well, there are two things. One, this should never have been had a default value, and that's what caused the bug to occur. So now I don't have two functions that take the same number of arguments. The fact that they took an equal number of arguments allowed for this to be incorrectly interpreted, where the false got interpreted as somehow as the last argument of this. There's a false here. No. Yeah. In any case, don't allow for the possibility of errors by having two similarly named functions that can be interpreted in two different ways. I don't know how it came up with that interpretation, but it did. The other thing is, this default case should not contain any switches. In fact, it shouldn't contain this either. This should be no. There are no switches in this case. And I don't know how this deals with the no case. So that's this thing, right? Count should be 0. So that's only used in this one case where validate is false. Not an assertion here. It's an if and only if. That is, if I've requested validation, I should have switches to validate. And if I have switches to validate, I should have requested to validate them. Well, I don't have to request to validate, but definitely this is true. If I'm asked to validate some switches, there better be some switches. Implied is if A, then B. Right? The logical imply means A, B. That means if A is true, then B is true. If A is not true, that doesn't mean that B is false. But if B is not true, so all this implies usually use wiggle for not. That means that if B is not true, then A must not be true, right? because we know that when A is true, B is true. So if A were true, then B would certainly be true. So this if A then B is the same as saying if not B then not A, right? So that means that if B is not true, then A is not true. And if B is true, A may or may not be true. But if B is true, I think this also works out the same. One of these has to be, either B has to be true or A has to be false. Let's see if that's true. If B is true, doesn't matter, but let's make a truth table. If A is true and B is true, the result of this expression is true. That's consistent with the expression. If A is false and B is true, right, then that disagrees with this, right? We can't have A being false. Oh no, that's okay, that's fine. A can be false and B can always be true. A is true and B is false does not agree, because if A is true, B should be true, and if A is false, B is false. Well, if A is false, that doesn't say anything about B, so that agrees. So that's our truth table. 1, 1, 1. 0, 1, 1. 1, 0, 0. And 0, 0, 1. No, wait a minute. If B is false, A must be false. Right? So this, if B is false, A must be false. Okay. So what is that logical operation? Is that, now let's say that B or not A. Same thing. That expression is true in that case. A is false. So not A is true, so that's true. B is true, so that's true, right? And right? If they're both true, that's true. This is one of them is true. If A is false, not A is true, so the whole thing is true. If A is true, that's false, so this is false. And if they're both false, one of them is true. So these have the same truth table, so this expression is also the same. So if A then B implies B or not A. So another way you could write this is B or not A, this or not this. Oh, does that make sense? Either we're not being asked to validate the switches, or if we are being asked to validate the switches, then this has to be non-null. So when we are being asked to validate the switches, this is false, and therefore to make this true, this has to be non-null. Okay. A lesson in logic. That you can write these things. The way I've defined this is okay, x, y, not A or B, right? And if and only if, it's just A implies B, and also B implies A, so you can just double up on okay. And lastly, there shouldn't be any switch involved in this case. That is, I shouldn't be putting a default switch slash if I'm not providing, if I'm not expecting any switches. That would take away valid arguments in my program. As soon as this builds, if I have slash s here, I don't want this to end up in the switches list. I want that as another argument. I didn't ask for any switch handling. So if I run this, I indeed do get the extra argument that I should have. If I had switches, then it might not, the count will be different. Now, why is that bad? It's particularly bad, for instance, if I'm writing a program where the argument supplied is supposed to be a sub directory or something, right? On the internet, like temp. Suppose that's the argument I'm supplying. Well, according to if I defaulted slash to mean that's a switch, then I wouldn't get this argument. I would still get it, but it would be a switch, and then I'd have to put the slash back. But I don't know if it's slash or whatever. There's nothing to indicate that here. Okay, so that's my little addendum. There's two fixes. Oh, and I forgot one more thing. this just to do with the variable argument list pointer thing. I think I explained that. Well, I did explain that wrong because I wasn't really reading it carefully. Okay, so AP here is set to address of V passed in, or that's RC, plus what they call int size of whatever. Okay, so rounded to an int. Remember, only integer size things can be pushed on a stack. Okay. Now the V here is RC. Okay. Okay. So now AP will be pointing to the next argument after this call. Now, it doesn't show, I don't know if I can see AP is a number defined, which was VA list. So this here is VA list. It currently says, well, that's the value. What's it pointing at? It's pointing at a pointer 180 47 78. Whoops. And, that looks like D, there it is, D colon source root blah blah blah. Okay, so it is pointing at the next. This here, VA list, is pointing at this list of pointers. Okay, now this value, this second value, it's supposed to be the size of this argument. So whatever is here should go here, because it needs to advance to the next argument, so it needs to add this much more to VA list. To make sense of the macro, AP is incremented by the size of this type. Right? And then now, so AP has changed. Now we subtract from that what we just added to it, and that whole thing, this whole expression will evaluate to what it originally was, and then returned. And AP by the next line will be pointing at the next argument. That's this, and then this much will be added, and who knows what the next argument is? We don't check. Okay, so that's the second. Oh well, I'll glue this on the other addendum.